Hello, everyone. Now let's look at worksheet 10 solutions together. So chapter 10, we have two sample confidence interval. So let's look at this two sample question. So number one, find a 90% confidence interval for the difference between full attendance students exam 5 score and less attendance students exam 5 score. And we want to assume equal population variance. Okay, so 90% confidence interval. So we know alpha is 1 minus 0.9, so 0.1. And alpha divided by 2 equals 0.1 divided by 2, which is 0.05. Because it's always alpha over 2 for the critical value for a confidence interval problem. So and then the other info, we know sigma, assume equal population variance. So sigma 1, assume to be equal, but they're unknown because there's no info about population variance equals what. So then from less attendance data set, we have N1 sample size equals 9 and N2 equals 4. Just count how many numbers you have in the data set. The next one bar, so the mean for this less attendance data set is 73.889, and standard deviation, sample standard deviation is 14.76. Full attendance, X bar for the fourth number here, 97.75, and the standard deviation is 2.06. That's all info we know, right? We can write it out. And then we're gonna just write down the formula for a population unknown problem and assume they're equal. So then we have x1 bar minus x2 bar plus or minus the critical value. And this critical value, the degree of freedom is n1 plus n2 minus 2. And times SP, the pooled standard deviation. Because the population tell us they're the same, but we got two different estimate of the same parameter. So we have to pull that info together to get just one estimate for the same standard deviation, sigma 1 and sigma 2. So we pull the info together just by this weighted average. N1 minus 1 times x1 squared plus n2 minus 1 times x2 squared over the degree of freedom. Then we have the pooled standard deviation 12.63, and then we can plug in the formula, and then the confidence interval is negative 37.49 to negative 10.23. So this is a negative to negative interval. That means the mean difference, because population mean difference, right? That is for mu1 minus mu2. So the mean difference mu1 minus mu2 is smaller than 0 because the interval tell us is definitely negative. So mu1 minus mu2 equals 0 also indicates mu1 is smaller than mu2. So less attendance students grade on average slower than full attendance student grade. That's what we can get from this confidence interval. That's question number 1. Number 2, repeat the previous question when we assume they're not the same. So if we assume they're not the same and also sigma 1, sigma 2 unknown, then the formula change to the critical value change, and then we don't have to pull that the estimation together because they're not the same. So definitely two groups got different estimate. So the critical value is t sub alpha over 2. That's remain always the same, but degree of freedom changed to the smaller of the degree of freedom. So it's 3. So that's the critical value. And then square root of s1 squared over n1 plus s2 squared over n2. So critical value times the standard error, and then that's the point estimate because we want to look at the mean difference. So sample mean difference is going to be the point estimate of the population mean difference. So plug in we got negative to negative. So we can still get the same conclusion. And the interpretation, we're going to say we're 90% confident that the true population mean difference is from negative 35.69 to negative 12.03. That's number 2. Number 3, given the information below, we want to find the 99% confidence interval for the population mean difference. So last attendance, full attendance, sample size, both 100, sample mean, x1 bar, x2 bar, population standard deviation. So know that we have population term here. That means is sigma 1, sigma 2, known case. So then we need to look at the z critical value. So z sub alpha over 2, which is z sub 0.005. So that's 2.576. We can check that from the standard normal table or using the t table, the bottom row of the t table that give us the same info. And then just using the formula, point estimate plus or minus the critical value times the standard error, plug in all the known info. So that is negative 21.39 to negative 18.61. Okay. That's question number 3, and that's all for worksheet 10 solutions. Thanks for watching.